Hello dear students, welcome to CS Digital Classes. Let us know about Kohlrausch Law today. Kohlrausch Law is an important law of electrochemistry. So let us understand what is electrochemistry first. So electrochemistry is the relation between electrical and chemical energy of substances. How the chemical energy gets converted into electrical energy and how electrical energy is then useful to us is dealt in electrochemistry. Now, some substances in the nature, some substances pass electricity. They conduct electricity and some do not. So we all know that the substances that allow electricity through them are called conductors and that do not are called as insulators. So even though there are mostly substances among the conductors, there are different substances which conduct electricity. Now let us know about. So we all know that all metals are conductors. So they conduct electricity with the help of moving electrons. As the metals contain valence electrons, free electrons, these electrons carry the electricity from one place to another. There are also other substances called electrolytes, which are a special case of conductors which conduct electricity by the migration of ions. That means movement of ions. So these substances are highly studied in electrochemistry. So the migration of ions or simply movement of ions. Electrolytes are substances or salts that are dissolved in water like NaCl, KCl. These are salts. When dissolved in water, they ionize. That means they divide into ions, Na plus and Cl minus. KCl will convert into K plus and Cl minus. Now these ions, cations and anions, will move from one place to another and conduct the electricity. Such substances are called as electrolytes. NaCl and KCl are called as electrolytes. Now this dissociation of electrolytes into ions in the presence of electricity is called as electrolysis. Breaking of a salt, an electrolyte, into its component ions in the presence of electricity is called as electrolysis. Now electrolytes are of two types basing on their dissociation. How are they divided? They are divided into how are they broken? Basing on that, they are divided into two types: weak electrolytes and strong electrolytes. Weak electrolytes, they do not dissociate completely. That means, for example, if we take acetic acid, CH3COOH, while electrolysis is carried out, acetic acid does not dissociate completely. That means after running electricity for some time, still we can find acetic acid molecules directly in the solution. But whereas in case of NaCl and KCl, we cannot find such molecules. The whole molecule NaCl, whole KCl cannot be found. All the molecules of NaCl and KCl will be divided into their component ions. Such compounds are called as strong electrolytes. They dissociate completely and the dissociation is also rapid. That means they break down very easily and very fast. Such substances are called as strong electrolytes. There are some other terms in electrochemistry. Let us see them. Now the first word is conductance. Conductance is the capacity of an electrolyte to allow the electricity, which is denoted by capital C. One more term, specific conductance. Conductance of an electrolyte when the electrolyte is placed between two electrodes. Electrodes are anode and cathode. Anode and cathode. Anode and cathode, when the electrolyte is placed between these two electrodes with unit area of cross section. Area of cross section is unit, that means 1. And they are separated. These two electrodes are separated at a unit distance 1. That is specific conductance denoted by Greek letter K, kappa. And equivalent conductance is the conductance of a solution with 1 gram equivalent of electrolyte. That means if NaCl, 1 gram equivalent of NaCl is added in a solution and that the conductance of this solution is called equivalent conductance denoted by lambda E. Similarly, molar conductance is when 1 mole of electrolyte is present in a solution, the conductance of that solution is called lambda M. The molar conductance are denoted by lambda M. Coming to Kohlrausch law. Now, as we have understood the terms of electrochemistry and what is electrochemistry, let us know about Kohlrausch law. Kohlrausch law states that equivalent conductance, that means lambda E, at infinite dilution. Infinite dilution means the dilution is very high. That means more amount of water is added to the electrolyte, which is denoted by lambda E naught, 0, of an electrolyte is the sum of equivalent conductances of cation and anion at infinite dilution again. That means lambda E naught of the electrolyte is equal to the sum of its, suppose if we take NaCl, this lambda E naught of NaCl is equal to lambda Na plus of lambda at infinite dilution of Na plus and lambda at infinite dilution of Cl minus ion. So cation and anion. This is Kohlrausch law. So this Kohlrausch law was defined, or there is an experimental basis for this law. Kohlrausch has conducted many experiments on, especially on strong electrolytes, and observed differences that in equivalent conductances at infinite dilution for any two cations or anions. See here they have given the examples NaCl, KCl. So here both the anions are same but cations are different. So the difference between these two, the equivalent conductances, is similar, 21.2. Similarly, if the anions are changed, Na and K again here 21.17. Here NaBr and KBr 21.20. So the difference is almost same. There is a negligible difference between the equivalent conductances. So this is how he had come to the conclusion that the equivalent conductance at infinite dilution of an electrolyte is equal to the equivalent conductances of its cation and anion. So there is no dependence of the equivalent conductance value on the nature of ions. Whatever may be the cation or whatever may be the anion, it will be same. Hope you understood all the topic properly. Thank you.